We're going to continue our look at Python data types by looking at objects. Up to now, we've seen several types of values that Python can store: ints, floats, Boolean values, strings, lists. In Python, every value is actually stored in memory as an object. Think of an object as a container. Objects hide the complexity of storing how the information is represented in memory and its type. Traditional languages like C, BASIC, Fortran, these data types are stored directly in memory locations. Now, it's beyond the scope of the course to really go into the details of that, but you should be aware that Python is an object-oriented programming language. So, as we mentioned, think of an object as a container. Every object has two things. It has a type and it has a value. So we've seen in the integer, for instance, the type is int and it has a value. String, we have a series of characters with the type string. So if we have a variable, for instance, I type a equals 5, a being the variable. A doesn't have a type. A is just the name of the container, and the container is of type int. That contains a value 5. So if I did a type of A, we can see it's of class int. So the variable is just a name that points to an object. The class is a type whose values are stored in objects, and class is an important term for object-oriented languages. So we can think of a class as being a collection of common elements. All the dogs are a class. A particular dog would be an instance of that class. So every Python type is a class. So integers are a class, strings are a class, and so on. Now, every class has certain ranges of variables, a certain range of values that its variables can have. So for integers, they can be very, very large, and it really depends on the CPU, the computer that you're running Python on. For instance, 2 to the exponent 1024 can be the size of some integers. Floats are usually a little smaller in size, 64 bits. So we may get 2.00. We may not be able to get an exponent of 1024. So if we want to look at how large some of this is, we see we get a very large number. But in a float, if I try to make that a float, it's using a smaller number of bits to represent floats, and we'll actually get an error. So you can't make numbers arbitrarily large. This also shows a problem that we'll get to later, is that if we try to change from one type to the other, if I have an integer and I want to change it to a float, I may not have enough storage for that value to actually do that change. Now those are fairly fine details, and likely in this introductory course you won't run into those problems. Large numbers in Python use scientific notation to represent the numbers. So if we have 2.0 raised to the 100th power, we'll get a number like this. So the E and the plus represents times 10. So if we were doing this in math, this is how the computer represents 1.267 times 10 to the 30 power. So this times 10 here is represented by the e and then the plus, meaning a plus exponent. Python provides various operators for its number types. And by operator we mean the plus, the minus, the multiplication and division and so on. So all these are operators here. It also provides functions. So ABS is the absolute value of x. This is a table that shows if x and y are integers and we do a sum, what is the result? Here's the type of the result. It's an integer. In fact, if you perform this operation on all these integers, it will always produce an integer except for division. So if we have 5 divided by 2, we would get a float returned. There are also comparison operators that you can do on integer or number types, various number types. So these are the various comparison operators we can do: less than, greater than, equal, not equal to. And this will return a Boolean value, true or false. So let's look at this comparison example that we have here. 3 is less than or equal to 5. And we can write it this way. You can't write this with this statement in other languages, but we're also going to test to see if 5 is less than 8. So here 5 is, if we look at this, this is actually saying 5 is greater than or equal to 3, which is true, and we're saying 5 is less than 8. Well, that's all true, so we should get true out. If we did this, if we said 5 is greater than 3, but 5 is less than 2, we'll get false. Let's look at order of operation, and sometimes it's not clear what happens. For instance, let's suppose we have 2 times 3 plus 5. Now we should know from math what happens, but one question is, well, what do we do first here? Do we do the addition or we do the multiplication? Now normal precedence in math says that multiplication is done before addition, and this is true of all computer languages as well. So here you can think of there being an implied bracket, so we're going to do this first and then the other, or that's what we think. So we'll see if that works out. If we execute that, we should get 2 times 3, which is 6, plus 5, which is 11. What if we have something like this? Here it's not really obvious. We could add the 4 and the 6 and get 10. Say 2 minus 10 gets minus 8. Would that be the right answer? No, the right answer is 4. So what happens when everything has the same precedence, minus and plus, the subtraction and addition have the same precedent, is that operation occurs from left to right. So what are the rules? Well, order is evaluated explicitly using brackets. So if we use brackets, that's going to happen first. If we don't use brackets, or once we have an expression inside of brackets, then order happens implicitly using precedence. And this table here shows the order of precedence. So an index operations done first, exponentiation, and onwards down through the list. So you can see that multiplication and division and modulus arithmetic is all done here, addition and subtraction, and then your comparisons are done. Finally, if you have what are called compound, Boolean, or, and, those are done next. So what we wanted you to do right now is to write down each of these on a piece of paper and put brackets around how you think this should be executed according to the laws of precedence and left to right. So we'll do the first one for you here. The order of precedence says that these are conditional tests. This is a Boolean expression. The order of precedence says this is the add and subtract is done first. Then we'll do our conditional tests here. And finally, the results of those are ORed together to give you a final Boolean result. So list the rest of these, put brackets around, see what you get, pause the video, and continue once you've completed this to check your answers. Look at the answers here. We can see that each of these, the list is computed, the unary minus is computed, and the minus 10 is computed. And then what happens is we go from left to right. So we do the multiplication of these two terms. We then do a comparison here. So that's the yellow brackets. And finally, we take that whole result and find out if it's equal to 0. In the next one, we do the list. We get an answer. The unary minus of 3, the minus of 10. And again, we go left to right, but this is also implied in these brackets here. We'll do the list times here. So that's done. And finally, we do a comparison to minus 10. Once we've done that, we check to see if that result is in this list. The exponential is done first here, and then the multiplication. Because of the order of precedence, exponential is done ahead of multiplication. Here, the division is done, and then the result is checked to see if it's in this list, because this has a lower precedence in this. Let's look at creating objects. We can create objects in a couple ways. If I say x equals 3, it's going to create an object, and it's going to assume that that should be an integer object because of what I've written there. I've just written 3. But I can sort of explicitly define that I want to create an integer by using the term int. And this term is called a constructor. And it's used to what's called instantiate an object from its class. So here I'm creating, instantiate or creating a new object based on the integer class. You can do this for all of the types. If you just do this, it creates a null object. For ints and floats, it gives it a 0 value. If I do, what we'll find there is we'll get a null string. So if I do x, it shows the quotes. There's nothing in between the quotes, so it's a null string. And you can do this for lists as well. What happens if I have expressions with different data types? For instance, true plus 5. It doesn't really seem to make any sense until we look at this diagram here. And this shows that an integer is really a subset or a special type of a float, and a Boolean is a special type of an integer. In fact, true and false actually have values of 1 and 0. True representing 1, false representing 0. So true plus 5, what Python does is says, I've got to convert this to an integer. I'll give it a value of 1. Add it to 5, I'll get 6. I'm going to add that to a float, so I'm going to take 6 and change it to a float, and I should get 8.34. So let's see if that's true. We get 8.34. We mentioned before that integers can be much larger than floats. Sometimes you'll get some errors if Python tries to do a conversion. If you have a very large integer, it won't always convert to a float because it may be out of the value, and you'll get that error message that we showed earlier. These constructors can be used to change from one integer type, or one data type to another. For instance, if we do int 3.4, that is, we want to convert 3.4, which is a floating point value, to an integer, it converts it to 3. What happens is the decimal point gets dropped. Minus 4.5, we'll get minus 4. I can also convert an integer to a float if I need to. What about strings? Let's suppose I've got an integer, or let's suppose I've got a string, and I want to convert it to an integer. Because strings are letters, they can't be added directly. Sometimes it doesn't make sense. And here I'm saying convert this to an integer, the string 3.5. Well, 3.5 doesn't represent an integer, so we'll actually get an error there. If we did this, now it makes sense. It'll convert it to a float. If we use this, we're actually taking a number which is a float and converting it to a string. So now it's a series of characters. So in this next exercise, we want to see what type of objects do these expressions evaluate to. So if I were to type false plus false, what would I get out? Would I get an integer, a boolean, and so on? So for each of these, on paper, write what type of data type do you think you could get, and try it out at your Python shell. See if you're correct. Pause the video now, and when you continue, we'll give you the answer. So here's the answer to those. False plus false, we're using this operation, so that's an addition, so it converts these two numbers. False is converted to an integer of 0. 0 plus 0 is going to give us 0, and that is of type integer. So this is going to return an integer. Here, if I evaluate this, I'm going to get 18.0. We can see that's returning a float. So because we have a float here, it converts this to a float. And once this is a float, usually when a float is combined with an integer, the result is a float. Here we're doing all integer operations. We're not doing division, so the result is an integer. Finally, we're doing a comparison here, which is going to return a true or a false. We're doing a Boolean comparison, an OR here. Again, I'm going to get a true and a false on this side, so I get true or false, or true or false. I'm going to get a Boolean out here, that is either a true or a false. So we have bool, integer, float, and integer. A class or type defines similar objects. But a class also contains a set of all operators and methods that can be applied to objects of this class. We'll give an example here. Here we have created a list, pets. We've got 2 items in our list. I can create the append method to this, and what I'm going to do is I'm going to add to that list using a method. There's another method I can use on list class objects. I can find out how many instances of dog I have in my list, which is just 1. I can reverse the order of the list. And if I ever want to find all the methods that I can use for the list class. I can go help and then use the name of the type or class. So for list, whoops, we get a big long list here. So we can add things. Here somewhere we should see our append, copy, count, and a little bit of text that sort of describes a little bit how to use this. So that concludes our look at objects and classes. Try the exercise in this section and see how you make out.